Hello, this is Team 8's final presentation. We are Grand Engineering. There's myself, Katie, with Due Diligence, Andy with Traffic, Amiali with Water, Billiam with Structures Pedestrian Bridge, and Joaquin with Geotech. This is Katie Sinclair. I'll be starting off the presentation with Due Diligence. A quick overview for this presentation. I'll begin by talking about the project location and current description of the land, then go into detail with the land use plan and highlighting the key feature being the Rise and Shine Stadium. I'll talk about the cost for the due diligence section of this project and the sustainability and value added to the community. To begin, this project is located at the southwest corner of the Loop 202 in the city of Phoenix, and it is 571 acres. These 571 acres are bound by West Ray Road alignment to the north, South 35th Avenue alignment to the east, West Chandler Boulevard alignment to the south, and South 43rd Avenue alignment to the west. This site has a current zoning of RE35, which is single-family residential, and is surrounded by the South Mountain Preserve. It has a natural drainage feature going from the northeast to the southwest and has an average slope of 2.3%. The land use plan is shown on the right with 9 different land uses. The magenta is going to be a high school. All of the blue is going to be single-family residential. That light purple is going to be multifamily residential. The red is going to be the Rise and Shine Stadium. The yellow is going to be commercial. Orange is going to be offices. The cyan is going to be the water/wastewater facilities. Green is going to be the park, and then that darker green is going to be open space that will remain untouched. A key feature for our site is the Rise and Shine Stadium that is located in Parcel 8 near the freeway for easy access. It'll seat 40,000 people and will help develop the economy and have a possibility of hosting a Major League Soccer Cup. This site will cost $10 million to purchase. It'll have conceptual review service fees of $2,700 and base review service fees of $405,000. The total due diligence cost will be almost $11 million. We as Grand Engineering are recommending the use of solar panels, green waste, and recycling throughout the site wherever possible, and especially in the Rise and Shine Stadium. Rise and Shine will provide job opportunities, offer entertainment and shopping experiences, and be a place for residents to call home. It'll benefit communities through youth programs, community centers, community events, and funding of schools and emergency services. To summarize the due diligence portion of the Rise and Shine community, it consists of 571 acres in the city of Phoenix, is surrounded by the South Mountain Preserve, has 9 different land uses with the Rise and Shine Stadium being the key feature, has a total cost of roughly $11 million, and will guarantee to offer a home, develop the economy, and maintain a safe community.
Hello everyone, my name is Andy Atondo and I will be presenting the traffic analysis done on the Rise and Shine site. The Rise and Shine site is 571 acres located off the South Mountain Freeway. There are 16 parcels with 9 land uses. Currently, there is one exit that promotes access to the site. It is called V. Cueva Way. The land contains a road called San Juan Road and it does not have any classifications yet. The only traffic volumes available are the proposed volumes on the freeway for the year 2035. Here we have the proposed land use plan. On event days, the southwest corner will be highly congested due to the visitors of the Rise and Shine Stadium. These are the roadways that will travel through the site. All the names come from existing roads that align elsewhere. The freeway is clearly shown and the boundaries are marked as dotted lines. Trip generation calculations were the first calculations done. The rates were taken from the trip generation manual. The total weekday trips generated from each parcel were the numbers that were used for the next calculations. The most trips were generated from parcel 9 and parcel 12. On this slide, you can see the percentages of cars driving in and out of the site. These are the directions of approach. Before starting the trip distribution and assignment calculations, the roads needed to be broken up into segments. A segment is a portion of a road. The names and colors to these segments match those that will be seen in the upcoming slide. For the trip distribution calculations, each road and all segments were separated. There was a percentage assigned to each segment that described how vehicles were traveling through the parcels. Every total at the end of a road was equal to 100%. In order to get the correct number of trips assigned, you needed to take the corresponding trip distribution percentages and multiply them by the corresponding trips generated. Every total that was calculated for each road was the annual daily traffic for that road. Using the annual daily traffic numbers from the trip assignment calculations and the City of Phoenix roadway classifications criteria table, we were able to classify the roads as either local, collector, or arterial roads. This is a diagram that illustrates all local, collector, and arterial roads that we have traveling through the Rise and Shine site. This is just a summary of what the table was showing in the previous slide. There are a total of 53 intersections in the site. For each intersection, we needed to determine if a traffic signal was needed there. To do that, we used the signal needs criteria table that is presented here. Here's an image that shows all the traffic signals needed for our intersections. Every intersection that did not need a traffic signal was issued a stop sign. The cost section for the traffic analysis included traffic signals, red light cameras, and stop signs. The total cost was $11,697,260. This cost included the initial implementation and annual maintenance of each system. Enforcement of carpooling and ride-sharing will create a sustainable environment. The range of areas to relax and hang out will draw visitors to the site. Being the home of the Phoenix Rising Football Club will be the most desirable feature.
Hi, my name is Amiali Santibáñez, and I will be presenting the Water Resources discipline. A quick overview of what I am going to be presenting is the anticipated water demands, the water system layout, and the sustainability approach. The anticipated water demands were calculated based off the City of Phoenix design standards. The demand factors that were utilized are displayed in the table. For the 16 parcels, the average day demand totaled to 1,540 gallons per minute. For the peak hour scenario, the demand was 2,620 gallons per minute. And for the peak hour plus fire flow scenario, that totaled to a demand of 5,620 gallons per minute. Parcel 16 was determined to be the highest fire flow requirement, and that had a fire flow factor of 3,000 gallons per minute for 2 hours. The water system layout consisted of 3 wells, 1 tank which has a diameter of 83 feet and a height of 42 feet. There are 40 8-inch water mains and 31 12-inch water mains. And this water system layout totaled to be $5.2 million. One assumption was made during this modeling process, and that is that the site was assumed to be flat, and this is due to the original elevations that the site has. The tank was also not included for modeling purposes. For the sustainability approach, the water discipline wanted to include the community, and the residential units will be required to meet the LEED V4.1, which are requirements set by the U.S. Green Building Council. An example of the LEED V4.1 requirements is the homes will be WaterSense labeled, and this will be done during the design and installment process. And by implementing these design factors, this will help reduce the amount of water that is being utilized. To keep the community informed, summary reports will be generated, and this will update the community about their water usages. And the summaries will include groundwater level reports and different tips on how water usage can be minimized throughout the community.
Hello everyone, my name is William Ko. Today I'm going to share about the project that I did for my senior science class. For this project, I'm a part of grant engineering team, and I'm responsible to design a new pedestrian bridge that crosses over the wash. In order to calculate the required dimension of the bridge components, the following design code we use as shown on screen here. On this slide, the left figure shows the location of the bridge and is located over the wedge between parcel 8 and 11 of the property. On the right figures, it shows the length of the wedge that measured on the Google map, and it is 36 feet. For the design loads, dirt loads and live loads of the bridge or the component value were given in H2 LRFT manual books, and the only set weight of the deck needed to be calculated as shown in the table on the left. And then we can get the shear and moment diagram can be obtained according to the loads information, and the maximum moment was found as 883.6 cubic feet. I used the AutoCAD software to design this bridge, and the dimensions can be found on the screen here. This is the first alternative design of the project, and it's used 3 components of W27x84 steel girder, and as you can see on the slide, the cross-section view, dimension and property information can be found here. The second and last alternative design of this project is using 3 components of type 1 H2 I-beam concrete girder, and cross-section view, the profile view, and then the plan view of the roadway is shown here. The total cost summary for both alternatives, and the total cost for the steel girder bridge is $156,772, and concrete girder bridge is $156,624 in total. After analyzing both the design, it found to be steel girder bridge is the best choice for the clients than concrete girder bridge, because steel is the most environmentally friendly materials than concrete girder bridge. I believe this pedestrian bridge project will add value to the property, because it will bring safer, easier, and reduced traveling time experience to the client. For sustainability purpose, we will use solar power panel for the lighting on the bridge and steel material than concrete.
Hi, I'm Joaquin. I'm Team 8, and I will be discussing the Geotechnical Report. Summary of my report, I'm going to discuss the proposed development, the geological exploration, laboratory results, foundation recommendation, sustainability, and cost estimation. During the field explorations, there were no existing structures on the development, meaning that there would not be an opportunity to retrofit existing foundations. The site is mostly composed of a gravelly surface and a clayey sandy subsurface. Areas of subsidence are shaded in yellow with the highest recording value of 0.4 inches. The map indicates no subsidence on the development. According to the U.S. Geological Survey, Phoenix is not in an earthquake hazardous area. Using the data retrieved from the Arizona Department of Water Resources, the water table is at a depth of 965 to 1,015 feet, indicating that it does not need to be considered in the design calculations. Location of each boring is shown on the map below. Using a hollow stem auger, the average blow count end value is 27. The adjusted blow count with 60% hammer efficiency is 40 at a depth of 3 feet. From the laboratory results, the average plasticity index is 26, the moisture content is 10.2%, dry density is 100.2 pounds per cubic feet, the unit weight was 110.1 pounds per cubic feet, and a friction angle of 50 degrees. Using Terzaghi method to calculate the bearing capacity, the average ultimate bearing capacity is 30 kips per square feet. Using a factor of safety of 1.5, the allowable bearing capacity for structures is 20 kips per square feet. Using the previous data, it is recommended that lightly loaded structures like residential homes use slab on grade. Other shallow foundations like spread footing be used for multifamily and commercial buildings. Heavy structures like stadium and school shall use a pile foundations. Recommended foundations of each land use is listed in the table. Retaining wall is along parcel 14 shown on the map. It has been evaluated for 4 modes of stability by checking the factor of safety with respect to the overturning moment, sliding, bearing capacity, and eccentricity, and all meet requirements. To promote sustainability, piezoelectric devices can be placed under roads, preferably asphalt pavements, to capture mostly kinetic energy from vehicles along with geothermal energy, and converts it to electrical energy. It can be a direct source of power for city infrastructure, reducing the use of external power sources. The savings will reflect on monthly maintenance costs. Finding the volume and quantity of each foundation using a unit price of concrete of $90 per cubic yard, the estimated cost is close to $2 million. References. To summarize the presentation, I discussed that there were no existing structures on the development. The site is mostly composed of a gravelly surface, clay, sandy subsurface. I mentioned that there is a deep water table, no subsidence or seismic activity. I addressed all the recommended foundations for each land use, the retaining wall, and the estimated cost is $2 million for the Rise and Shine development. This concludes Teammates' presentation. Thank you for watching.